Today, we're going to be talking about section 3.1. This is about solving quadratic equations by taking square roots. So let's start by defining what we mean by a quadratic equation. So a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equal to 0. Now, today, we're only going to focus on a more general or a special situation where we're having quadratic equations in this form, i.e. where the b term is 0. Now, this is a special case where things are a little bit simpler. As we work outward from this case, we'll look at other situations where we do include this b term, and things get a little bit more complicated, but this is a good kind of starting place. Now, there are three primary methods that we're going to talk about using to solve a quadratic equation, because solving a quadratic equation is not exactly the same as solving like a linear equation. So we have a couple of methods. Some of these we've already talked about. The first method is graphing, and this is a method that we've looked at before when we talked about solving absolute value functions. So suppose we have something like x squared equals 16, and we want to solve this by graphing. So what I do is I'm going to translate this kind of into a system of two equations, where I'm going to have y equals the left-hand side, and y equals the right-hand side. So again, when I say left-hand side, right-hand side, I mean of the equation. So I would type this into my calculator. So y equals 16 will be a horizontal line. And then y equals x squared is going to be a parabola. So it's shaped a little bit like this. And then I'm just going to look for the intersections using my graphing calculator. And I get that the two answers are 4 and negative 4. Now, again, graphing, perfectly reasonable method. Not terribly practical because it's rather time-consuming and requires maybe some estimation. And if these aren't exact values, then that kind of all goes out the window. A algebraic method that we can use is factoring. So, to solve via factoring, what I want to start by doing is getting the equation equal to 0. So I'll just subtract 16 from both sides. And now, what I'm going to do is I'm going to use a special factoring property called the difference of two squares. And I abbreviate this dots when I say it for difference of two squares. And the difference of two squares factoring pattern says that if you have something squared minus something squared, that's the really same thing as the square root of each added together times the square root of each subtracted together. So if I look over here at x squared minus 16 equal to 0, I see something squared, because x is something squared. I have a subtraction symbol, and 16 is something squared. So I can apply this difference of two squares factoring pattern by saying x plus 4 times x minus 4 equal to 0. Now, does it matter which one I write first, x plus 4, x minus 4? It does not. Now, I can apply something, another special property called the zero product property. And what this says is if I have some things that are multiplied together that equal 0, then at least one of those things has to be equal to 0. So if I look here, I have two things that are multiplying to equal 0. So that tells me that either x plus 4 equals 0 or x minus 4 is equal to 0. So it tells me my two solutions are negative 4 and positive 4. Again, a reasonable method, a useful method. The problem is that every quadratic that we have going to be able to satisfy this property neatly? Maybe not, right? Certainly if there's not a subtraction symbol between them, we're going to have ourselves a little bit of a problem. And if things can't be easily square rooted, we're going to have ourselves a little bit of a problem. The third method is just using that reverse order of operations with a square root. So again, if we go back to our example of x squared equals 16, here I can square root both sides. Again, maybe we should start here. So we'll start doing the reverse order operation. There's no addition or subtraction to undo. There's no multiplication or division to undo. So now I'm going to worry about undoing my exponents. So the way to cancel out a squared is with a square root. So when I take the square root of something squared, I get a plus or minus. And the square root of 16 is 4. So why am I getting this plus or minus here? Well, let's think about this for a moment. If I have x squared equals 16, that means if I take a number like 4 and I square it, I should get 16. But that also happens when I square a negative, because when I take negative times negative, I also get a positive. So whenever you take the square root of both sides, like we did up here, both sides of an equation, you get a plus or minus. So this is the method that we'll focus on for this section. Let's look at an example that's maybe a little bit more complicated. So let's say we have this guy. So 2x squared minus 27 equals 0. To solve this, I'm going to start by applying the reverse order of operations. So I'm going to add 27 to both sides. And then I'm going to cancel out the multiplication by dividing both sides by 2. And notice that I'm not writing 27 over 2 as a fraction or as a decimal. I'm going to keep it as a fraction. At this point, you need to keep these as fractions. Do not make them decimals. And now I'm ready to square root both sides. So my answer is x equals plus or minus the square root of 27 over 2. However, this is not going to be the form that I'm going to leave my final answer in. I'm going to want to simplify this, and there's simplifying I can do So to kind of the tools that I'm going to use to do this, I have two properties of square roots. So the first one is the product property of square root. It says the square root of a product can be the product of the square roots. And then we also have a quotient property. That says the quotient of or the square root of a quotient is the quotient of the square roots. And I'm going to be using these two tools to simplify this some more. So I'll begin by applying the quotient property. And now I'm going to apply the product property to the numerator. I notice that 27 is not a prime number. I could rewrite 27 as the square root of 9 times the square root of 3. And why would I have picked this particular way to rewrite 27? Well, let's actually say this first, I guess. Because when I apply the product property, as I do here, this is 9, so looking like an 8, the square root of 9 is something I can take the square root of. So I have 3, because the square root of 9 is 3, square root of 3 over the square root of 2. But we're also going to say, as a convention, we're not going to leave any radicals. That's a generic term for things like square roots in the denominator. So I need to figure out a way to rewrite this so that the square root of 2 is not in the denominator. Well, this isn't a difficult thing to do. We can do this process called rationalizing the denominator. And that'll take any square root that's inside the denominator and get rid of it, basically. So the idea is that we multiply the top and bottom of our fraction by the conjugate. And what is the conjugate? In the case of a one-term square root, so the conjugate of the square root of 2 is the square root of 2. And we'll look at some more complicated situations a little bit later on other more complicated conjugates. So, if I go back to this guy, what I need to do then, to get the square root out of the denominator, is multiply the top and bottom by the square root of 2. So if I look at this part, the square root of 3 times the square root of 2, I can go back and use the product property and apply it in this direction. Let's say we have the square root of 6. And the square root of 2 times the square root of 2 is the square root of 4, and that's just 2. So here is my final answer. So to kind of sum things up here, you can take a square root and multiply it by another square root, and you just write the product underneath the radical. Or you can take a square root, and let's do numeric examples. You take a square root times another square root, and you can just multiply them together. Note that this does not work for addition. This makes math teachers cry. And you can go in the reverse direction. So you can take something like the square root of 8, and you can write it as like the square root of 4 times the square root of 2. And the advantage of being able to do that is things like the square root of 4 might be able to be simplified. And the same thing kind of goes for division. So if you have like the square root of 32 divided by the square root of 4, you could write this as the square root of 32 over 4. And the advantage there is I can reduce this fraction now. It becomes the square root of 8. And we could simplify that using the same thing as there. Or if you have like something like this, the square root of 9 over the square root, or over 16, we can break the square root up and have the square root at the top and the bottom, and then we can take each one of these square roots separately. So it just provides me a nice little framework on how to simplify expressions with radicals in them. So here's my question. What about things like, for example, 3x squared negative 3x squared minus 15 is 0. Well, we can do the same thing. So we'll start by adding 15 to both sides. And then we'll square root both sides. We get plus or minus the square root of negative 5. Does anybody see a problem here? How in the world are we getting a square root? How can we square root a negative number? How can I take something squared and get something negative? That doesn't seem like it makes sense. Well, here's the thing. We're going to make it make sense. And you're like, whoa, hold on here, Mr. Gulick. Make it make sense? We're going to define a new type of number called the imaginary number. And we're going to call this imaginary number. We're going to use the symbol I, like a cursive I to do it, so I always put a little tail on mine so it doesn't look like a semicolon. And it's going to equal the square root of negative 1. So, for example, then, our square root of negative 5, I can use my product property and call this the square root of negative 1 times the square root of 5. And the square root of negative 1 is just 5. Or is just I, so we have I squared 5. So our answer here is plus or minus I squared 5. Now, your BS detector is going off at this and saying, whoa, 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 whoa. You can't just do this. And I would say, you've done this your whole mathematics career. You started in elementary school with addition and subtraction and having only positive numbers. But like when you tried to do 3 minus 5, you needed a way to write this, so we created negative numbers. And as you would move through elementary school, we had only like we started talking about multiplication division, and you had at that point only integers to work with, positive and negative whole numbers. But eventually you did something like 16 divided by 5, and you wanted to be able to write like 3 1/5. But you needed like rational. You needed these fractions. So you expanded and you had rational numbers. And you went further through elementary school and started talking more about divisions. And you eventually wanted to be able to do things like this be able to create decimals. And so we created started having the real numbers. And in addition, like in geometry, we needed pi, so we extended the real numbers to include these irrational numbers. So we've been doing this since really the beginning of your mathematics career. When we get stuck and we need a number or new kinds of numbers to represent things, we just kind of extend our number set. And that's really all we've done with these imaginary numbers here. So we say that you take the real numbers and add the things of the form a plus bi, that's an I. We call this set the complex numbers. So let's just do a couple examples of working with some of these imaginary numbers. So let's say we have 5 squared, or 5i squared. Well, we know from our rule of exponents, if we square a product, we just square each factor in that product. So 5 squared, well, that's 25. And we have I squared. What is I squared? If we think about the definition of I, we said that was the square root of -1. And the square cancels the square root. So we have 25 times -1, or negative 25. Interesting. Let's do another one. So what if we have negative I squared root of 2 cubed? Well, that's going to be negative I cubed times square root 2 cubed. So let's think about this for a minute. So I'm going to think about this negative I cubed as negative I times negative I squared. And the reason I wanted to do this is negative I squared is the square root of, or is I squared, which is just -1. And I'm going to think about the square root of 2 cubed the same way, as I'm going to think about the square root of 2 times the square root of 2 squared, because the square root of 2 squared is the square root of 4, which is just 2. So I have this, and if I kind of combine this together, I'm going to do -2 times -1 times a negative I gives me a positive 2i, and then we have that square root of 2 that I'm going to tack on again. So using these imaginary numbers, I can solve things like this. So I'll start by subtracting 9 from both sides, multiply both sides by 4, square root both sides. When I square root both sides, I get my plus or minus, and now I'm going to use my product property to rewrite this as -1 times square root of 36, or square root of -1 times square root of 36. Square root of -1 is I, square root of 36 is 6, and really the way I'm going to write this is 6i. Typically write the i's at the end. And that about does it here, folks. So again, the reverse order of operations is my primary method. In the homework, they'll ask you to do a couple of problems where we're asked to solve by graphing. So you just use your calculator and sketch a graph and approximate where the intersections are. And factoring. When you're using factoring, all the factoring will be these difference of 2 square situations. So they should be easy to do. You're just going to be using this pattern. And then you'll have a whole bunch of these solving with reversal of operations, where you have to apply our properties of square roots to simplify your answer, and use imaginary numbers if you end up square rooting a negative. So our homework for this lesson is going to be numbers 1 through 26.